Welcome to DC Digital Learning Session. I am Dr. Shobhan Kumar, working as Assistant Professor in Maharani Science College for Women, Bangalore. Today we have to discuss factorial notation, how to write the given polynomial in terms of factorial notations under the finite differences. The factorial polynomial has an important role in the theory of calculus of finite differences, which can be used to find the various order of differences. The factorial polynomial is defined as a product of n successive factors, which decreases by a constant interval of differencing h and is denoted by x to the power n, here within the bracket n. Thus, x to the power n is equal to x into x minus h into x minus 2h and so on, x minus of n minus 1 into h, where n is a positive integer and h is the interval of differencing. Therefore, x to the power 1, here n is equal to 1, we take it should be x. X to the power 2 is equal to x into x minus h. X to the power 3 n is equal to 3, we get x into x minus h into x minus 2h. We note that the zero differentiating, that means x to the power 0 is 1, then x to the power n is equal to x to the power n minus 1 into x in minus n minus 1. When h is equal to 1, x to the power 1 is x to the power 2 is x into x minus 1, x to the power 3 is equal to x into x minus 1 into x minus 2. Now difference of x to the power n. How to difference of x to the power n? Now using forward difference operator, delta of x to the power n, you can write down n, keep as it is. Here delta of this is like f of x. Delta of x to the power n is x plus h whole to the power n minus x to the power n. Now x plus h whole to the power n. Here using this, here x to the power n, here instead of x, here x plus h. Therefore, it becomes x plus h into x plus h minus h into x plus 2h minus h and so on, x minus n minus 1 into h. And after simplification, it becomes x into x minus h into x minus 2h and so on, x minus n minus 2 into h into x plus h minus x minus n minus 1 into h. Therefore, delta of x to the power n is equal to n h x to the power n minus 1. This is equal to n h x to the power n minus 1. Delta of x to the power n is equal to n h x to the power n minus 1. Similarly, delta square x to the power n is n into n minus 1 into n minus 2 h cube x to the power n minus 3. In general, this is very important. In general, delta n x to the power n, delta n x to the power n is n into n minus 1 into n minus 2 into 3 into 2 into 1 into h to the power n x to the power 0. But x to the power 0 is 1. Therefore, delta n x to the power n is here n into n minus 1 and so on 1 is n factorial into h raised to n. Delta raised to n of x to the power n is equal to n factorial into h to the power 1 n. Therefore, the difference of a factorial polynomial is similar to the rule of differentiation of x to the power n. It is like a rule of differentiation of x to the power n. We note that the reciprocal factorial of x to the power minus n is defined as x to the power minus n is equal to 1 upon x plus h into x plus 2h and so on, x plus nh, where n is positive integer. Therefore, delta of x to the power minus n is equal to minus n h x to the power minus of n plus 1. Similarly, delta square x to the power minus n is minus 1 whole square into n plus 1 into h square into x to the power minus of n plus 2. Okay. Now to represent a given polynomial in factorial notation, how to represent, how to write a given function or a polynomial in the form of factorial notation. Let f of x be a polynomial of degree n. Here f of x is given. Call it as 1. F of x is a0 plus a1 x to the power 1 plus a2 x to the power 2 plus and so on an x to the power n of degree n, where a0, a1, a2 and so on an are all coefficients of x as well as constants. Here a0 is not equal to 0, is always non-zero number a0. Then delta f of x is equal to delta f of x is equal to, here a0 should be 0. When applying delta, constant should be 0. Delta f of x equal to a1. Here it is like a differentiation. Here it is like differentiation. It becomes 2a2 x to the power 1 plus 3a3 x to the power 2 plus and so on n x to the power n minus 1. N x to the power n minus 1. Similarly, delta, and again applying delta on this, delta square f of x, it should be 0. It becomes 2a2 plus 3 into 2 into a3 x to the power 2 plus n into n minus 1 into an x to the power n minus 2. Therefore, delta 3 f of x is equal to 3 into 2a3 plus and so on n into n minus 1 into n minus 2 into an x to the power n minus 3. Proceeding further like this, delta n f of x is equal to n into n minus 1 into n minus 2 and so on, 3 into 2 into 1, an x to the power n minus n is 0. Therefore, delta n f of x is equal to n factorial into an. N factorial into an. The delta n f of x equal to n factorial into n. For x is equal to 0, suppose x is equal to 0, then f of 0 is equal to 0 in the given polynomial. Therefore, delta f of 0 is equal to a1, delta 2 f of 0 is equal to 2a2. Here already we know that here, if f of x equal to 0, x equal to 0 means f of 0 is a0. And then it becomes like this. Delta 2 f of 0 is 2a2, delta 3 f of 0 is 6a3, and so on. Delta n f of 0 is equal to an into n factorial. Here no x, no an into n factorial. Now equation 1 can be written as, here this equation 1 can be written as, f of x is equal to f of 0 plus delta f of 0 into x to the power 1 plus del square f of 0 by 2 factorial x to the power 2 plus del cube f of 0 divided by 3 factorial x raised to 3 plus and so on, plus delta n f of 0 by n factorial x to the power n. This is the factorial notation of given polynomial f of x. Now we discuss some examples. Express f of x equal to 3x cubed plus x square plus x plus 1 as a factorial notation. We can solve this problem by 3 methods. First method is here already earlier discussed, f of x equal to f of 0 plus delta f of 0 x to the power 1 plus and so on. Now at x equal to 0, 1, 2 and 3, we get here in this polynomial, take x equal to 0, x is equal to 1, x equal to 2, x is equal to 3. Okay, we get f of 0, we get 1, f of 2 we get 3, 1, f of 1 is 6, we get f of 2 is 3, 1, f of 3 is 94. The difference table for the above values, and write above values, here x and f of x 0, 1, 2, 3. Here x is 0, 1, 2, 3. X to here it can be written as x to the power 0, x to the power 1, x square, x cube, therefore 0, 0, 1, 2, 3. X, x, and f of x. F of x is 1. When x equal to 0, f of 0 is 1. X equal to 1, f of 1 is 6, and so on. F of 3 is 94. Now delta f of x, first forward difference. Already you know that. First forward difference 5, 25, 63. Second forward difference 20, 38, and delta 3 f of x is 80. Now we note that f of 0 is 1, delta f of 0, delta 2 f of 0, delta 3 f of 0. Now substituting in 1, we get f of x equal to 1 plus 5x to the power 1 plus 20 by 2 factorial x square plus 18 by 3 factorial x to the power 3. Therefore, f of x equal to 3x cube plus 10x square into 1 plus 5x to the power 1 plus 1. This is a required factorial notation of a given polynomial by using forward difference table. Here you should remember this formula. This is very, very important. Very, very important. Okay, whenever we can apply difference method, forward difference method, it is very simple. Okay, and the second method is here f of x, you can write the given polynomial. We can express in factorial notation, means it should be equivalent like this: ax to the power 3 plus bx to the power 2 plus cx to the power 1 plus d. Now already we know that x to the power 3 can be written as x into x minus 1 into x minus 2. X to the power 2 is x into x minus 1. And x to the power 1 is x itself plus d as it is. Now put x is equal to 0. Put x is equal to 0. Comparing these two, we get d is equal to 1. Okay, d is equal to 1 because this one 0. And in LHS, this is also 0, remaining 1 is equal to d. D should be 1. Put x is equal to 1 because x equal to 0, 1, 2, and 3. Okay. Here x is equal to 1. We get x is equal to 1. We get c. Here already we know that d is equal to 1. Then c is equal to 5. And x is equal to 2. X is equal to 2. We get p. Now we know that a, B, C, and D. Here A is here, or here comparing the coefficient of x cube on both sides, A should be 3. Now we know all the coefficients of x, A, B, C, D. Then put in this in this result, we get 3 here 3x to the power 3 plus 10x to the power 2 plus c is 5x to the power 1 plus d is 1. This is a required factorial notation of a given polynomial. This is another method. This is very simple compared to difference method. And the last one is synthetic division method. This is also very simple. While applying the method of synthetic division, the coefficients of powers of x should be arranged in descending order, counting 0 for the coefficient of missing term. Divide f successively by x, x minus 1, x minus 2, x minus 3, x minus 3, when degree is 3. Okay, here degree of the polynomial is 3. Suppose degree is 4, divide by x, x minus 1, x minus 2, x minus 3, x minus 3, like this. Okay, suppose degree is n, then divide by x, x minus 1, x minus 2, x minus 3, and so on, x minus n. Okay. Now by synthetic division method, here 3x cube plus x square plus x plus 1. Here coefficients of x, you can write first coefficients of x, just reducing the higher degree to lower degree. Here 3, 1, 1. Here 3, 1, 1, 1. You can write. In first coefficient, add to 0 to first coefficient. And adding, we get 3. 3 into 0, 0. And again adding 1. 1 into 0, 0. And again adding, it should be 1. 1 into 0 is 0. And adding 1. And adding 1. The last value, whatever we got here, it should be t. And again, here in first term, 0 adding. Okay, here 3 plus 0, 3. Here x minus 1 is no. This is x minus 1. And here x minus 1. Here x equal to 1. Therefore, here you put 1 is 1 root of the given polynomial. 1. 3 plus 0, 3. 3 into 1 is 3. And adding 1 plus 3 is 4. 4 into 1 is 4. Okay. Now 1 plus 4, 5. This should be C. It should be C. Here this is in decreasing order. B, C, D, A. It should be C. And again, first number 0 adding. 3 plus 0, 0. Here we can take 2 because here x minus 2 equal to 0, x equal to 2. Here 3 plus 0, 3. 3 2s are 6. 3 2s are 6. And adding 4 plus 6 is 10. This should be B. And remaining one more number, we can adding 0 to this. We get 3. Here we take x is equal to 3. Now here no values here. Therefore, this should be A. Therefore, A is equal to 3, B is equal to 10, C is equal to 5, and D is equal to 1. Now, substitute here A, B, C, D. We get required factorial notation of a given polynomial. Take another example in synthetic division method. In synthetic division method. Okay, express f of x equal to 3x cube minus 4x squared plus 3x minus 11 in factorial notation and express its successive differences in factorial notation. Here given polynomial, here by using synthetic division method, can use a synthetic division method, we get 3x cube minus 4x squared minus 3x minus 11 is equal to, here decrease 3, can take 3x to the power 3 plus 5x square plus 2x to the power 1 minus 11. Because here already by synthetic division method, here we know that here A, B, C and D. Okay. I can take this below. Now it's correct. This is a D, not C. Here A, B, C, D. Here put here, this is A, B, C and D. Okay, this is in factorial notation. Okay, by synthetic division method, it is very simple. Okay, here applying synthetic division method. Whatever here got, this is D, this is C, this is B and E. Okay, now f of x is equal to, f of x is equal to f of x is equal to 3x cube plus 5x squared plus 2x to the power 1 minus 1. They are applying delta on both sides here. Applying delta on both sides. Delta of f of x is equal to delta of 3x cube. It is like differentiation. 3 3s are 9x to the power 2 plus here 2 5s are 10x to the power 1. It becomes 2 into 1 is 2. It should be 0. Here differentiate the constant should be 0. And again applying here del on both sides, del square. Here 18x plus 10. And again applying del on both sides, del cube f of x is equal to 18. These are the differences. Okay, here express its successive differences in factorial notation. This is delta f of x, delta 2 f of x, delta 3 f of x. Suppose you can use the forward difference table. There also we got delta 3 f of x should be 18 only. 18 only. Next example is obtain function whose first difference is 6x squared plus 10x plus 11. Here we have to find the function f of x. Okay. Suppose given function is g of x. Let g of x equal to 6x squared plus 10x plus 11. Let f of x be the function such that delta f of x is equal to g of x. You can try 6x squared plus 10x plus 11. Now we shall express g of x in factorial notation. By using synthetic division method, we get like this. Okay, we get like this. This is C, P, and D by synthetic division. Applying delta on both sides, delta f of x is equal to 6x squared plus 10x plus 11. plus 11 is equal to f of x. Here delta f of x equal to this. Then f of x equal to 1 upon delta into 6x squared plus 10x plus 11. Therefore, f of x is equal to, here delta is a differentiation. Then 1 by delta is nothing but integration. Therefore, integration of x square is x cubed by 3. Here x to the power, we can write in factorial notation form. X to the power by 3 by 3. Here x square by 2 by 2. And here x plus constant of integration. We can write k. Therefore, f of x is equal to 2x to the power 3 plus 8x to the power 2 plus 11x to the power 1 plus k plus k. Again, x to the power 3 is x into x minus 1 into x minus 2. X to the power 2 is x into x minus 1. Okay. And x to the power 1 is x itself plus constant you can write down as it is. And simplify. Create f of x equal to, after simplifying, 2x cube plus 2x square plus 7x plus k is a required polynomial. Okay, here first difference is given. Here we have to find out the f of x. Okay, these are the references. Okay, let me stop the stage. Thank you.